Okay, you may remember that every normal distribution has a mean and a standard deviation, and those are kind of like an address for a particular normal distribution. So there's infinitely many normal distributions. Um, However, it'd be nice if we could take all those different normal distributions and put them on the same scale, like put them on some kind of standardized scale. So that's what the standard normal distribution is. And that particular normal distribution, the address, has a mean of 0. So the center of that normal distribution, that standard normal, is 0, just because that's really convenient. It's symmetric around 0, which is nice. And then the standard deviation, it wouldn't work for that to be 0, because we need some kind of variance. So the next easiest number is 1. So our mean is at 0, our standard deviation is 1, and that gives us the standard normal distribution that we see here, sometimes called the Z distribution. And you'll see some other signs in different math contexts. But here we have the curve graphed, and we want to know what portion of this standard normal is to the left of z equals negative 0.50. Let me just translate what this z represents. Z is the number of standard deviations above the mean in the standard normal. And so if we have a negative, that will always be below the mean. So this is going to be half a standard deviation below the mean. And if we look here at our standard normal, you can see here would be one standard deviation below. So we want to go half below. And then we have to look carefully if we're going to the left or the right. So in this case, we want to go to the left. So we'll shade everything to the left of that negative zero point 0.5. Now, this still doesn't tell us what portion got shaded. However, one thing you should always do on any problem that uses a t-distribution or a normal distribution is draw a picture like you have here, even if it doesn't require you to. So at least you can see if the portion you're looking for is below or above half, above 0.5, because that's the most common error in these types of questions, is getting the wrong side of what you're looking for. So if we grab the calculator here, you'll notice a couple keys that come into play. And if we want the area to the left of negative 0.5, notice here, probability that z is less than or equal to, I mean, it's basically exactly what we're looking for, 0.50. So we just plug that into the calculator and we get our answer set to 4 decimal places. So we'll grab those and put it here. Now, what if the question had asked to the right, because the button on the calculator only gives less than or equal to? We would still use the less than or equal to button to get the portion to the left, but here's where we would then subtract that from 1, and that would give us the portion to the right. So in this case, for example, we would take 1 minus this. That would be the white portion here. That would be everything to the right of negative 0.5.